Hey everyone, welcome to lesson 3 in unit 3. So far we've been talking about a lot of different types of word problems. We're going to continue that today in today's lesson. So what we're going to talk about today is steps to try and make sure that you're organizing your thoughts to solve your problems. Okay? So your aim today is that I can model and solve a problem by translating English word problems into algebraic equations. The last two lessons, we've only talked about expressions. So today we're going to talk about equations, how we translate into equations, and then how we go about solving them. So let's read. Although word problems can often be some of the most challenging for students, they give us great opportunities to refine our understanding of the relationships between quantities and how to manipulate expressions to solve equations. When you solve any real-world problem with mathematics, you are modeling a physical situation with mathematical tools, such as equations, diagrams, tables, as well as many others. As we work through these problems, try and make sure to always do the following. So take a look at this box, and I want us to work in this box right here, modeling and solving linear word problems. Step number 1 says, clearly define. Okay, clearly define the quantities involved with common sense variables and let statements. A let statement is saying something like, let x equal miles. We're defining what x is. Okay, that's an example. Number 2, use let statements to write out expressions for quantities you're interested in. So if I know that x equals miles, I could say something like maybe x plus 4. Now that I know that miles, I go 4 more miles. Okay. Number 3, carefully translate the information you're told into an equation. So in the problem, they're going to give you a lot of information. We're going to figure out how do I make that into something with an equal sign. And step 4 then, that's the do step. Okay? That is the doing step. You're solving the equation. Okay? And number 5 is a check step. Check for it being reasonable. If I get an answer where it says something like, the time is going to be negative 15. Can time be negative? No, this doesn't make any sense. So when you're solving a problem, think about whether it makes any sense. Okay? Just because you get an answer doesn't always mean it's right, and so we have to think about that sense making. Okay? So exercise 1, let's start off with a reasonably easy example. So exercise 1 says, the sum of a number and 5 more than the number is 17. What is the number? So let's do my splitting. So I see the sum of a number and 5 more than the number is. That is right there is the key word that I need an equal sign. Okay, so whenever you see words like is, will be, there are other examples on that paper that I passed out to you guys in class. There's all those examples. So if you see is and will be, that means equals. Okay? So part A says, first experiment with some numbers. So let's pick some numbers to experiment. So let's test the number, let's test the number 1. Okay? So this is saying the sum of a number, so there's 1. And there's my plus, and 5 more than the number. What's 5 more than 1? 6. Instead of writing 6, I could write, 5 plus 1, right? 5 more than the number is 17. Let's see if this works. 1 plus 5 is 6. 6 plus 1. Well, is 6 plus 1 17? No. So the number 1 doesn't work. Okay? How about we test the number 3? Okay, so here's the number 3 plus 5 more than 3, 5 plus 3. Will that give me 17? Let's try it. 3 plus 5 is 8. 8 plus 3 is 11. That didn't work either. No. Let's try the number 6. I'm just picking these numbers. Okay, so I have 6 plus 5 more than 6 will give me 17. 6 plus 5 is 11. Hey, look at that. 11 plus 6 is 17. I guessed correctly, right? This was my guess. But I don't have time to guess all the time. Guessing takes a very long time. We don't want to guess. So let's work on how we can always get this right the first time without having to guess. So exercise B. Now let's carefully set up let statements in an equation that represents the quantities you're interested in. So here's how let statements work. Okay, let's go back up to the problem. So I'm gonna let n be the number I want to find. Okay, n's gonna be the number I want to find. The other thing I don't know, and if I look in the problem here, so that's the first number, and I have 5 more than the number. So let's let n plus 5 be 5 more than the number. Okay? Now that I know these two things, let's put it together into an equation. So there's my let statements, and now I'm going to put them into an equation. So let's pick something other than blue here. Let's pick red. Now here's my equation. The equation goes back to what we learned in the last couple lessons. So I'm going back up to here, the sum of a number. So I already know that n is that number I've defined. And plus, so there's my first part, and n plus 5, 5 more than the number, is, there's my equals sign way up here, is 17. I've created my equation, right? So if I go back up to here, scroll up, I've defined my quantities. Check. 2, did I use my let statements? Check. Did I translate into an equation? I did. Now step 4 says solve the equation. So let's solve. First I need to combine my like terms. Remember there's like little invisible ones here. So this is like saying 1n plus 1n gives me 2n's. Carry down the 5, carry down the 17. To undo this, I'm going to subtract the 5 from both sides. The 5's cancel out and I have 2n equals 17 minus 5 is 12. Divide both sides by 2. The 2's cancel out and I get the number is 6. So I found my number. Okay? I'm going to put a box around it. 6. Okay? Let's try some more examples here. Exercise 2. The difference between twice a number and a number that is 5 more than it is 3. Which of the following equations could be used to find the value of the number n? Okay, well, first step, let's make our let statements. So the first let statement I want to make is let n equal the number that I'm looking for. And if I keep going, I'm going to see twice the number and a number that is 5 more than it. So this 5 more than it, I'm going to say, okay, let n plus 5 equal 5 more than the number. Okay? Now I need to create my equation. So, I'm going to pick a different color. I'm going to start at the beginning of my sentence. The difference between, so I know there's subtraction involved here, right? This is difference. Between twice a number, that's my first part, twice a number, and remember that's where my subtraction sign goes. So I have my subtraction sign right here. Right? Twice a number goes in front, so that's 2 times n. So 2n minus a number that's 5 more than it. So I'm just trying to get my colors good for you guys. A number that is 5 more than it, so that would be 2n minus n plus 5. Okay. Now, the weird part about this problem is when this says minus n plus 5, it's not just minus n, it's actually minus the entire thing. You're subtracting the whole n plus 5, so you have to put this in parentheses. And I'm going to show you why when we start solving. But if you have something like a sum or more than just one number and you're subtracting, you've got to put that in parentheses. Okay, so you've got to put in parentheses. Okay, now I go to my, what's the next word? The word is going to be is. That's an equal sign. Is. And then finally, what's the last part? 3. So it equals 3. Holy cow, that 3 turned out super weird. Let's try the different color. I don't know why that's doing that. There we go, let's try this one. Okay, 3. Okay. Now when we solve it, I'm going to explain why this one's a little trickier. Right? Oh, wait, look. Do we even have to solve this? Hey, we don't. Does this equation match any of my answer choices? Absolutely, it matches number 4. Awesome. Now notice, though, let's pay close attention. If I had done 2n minus n plus 5 equals 3 without the parentheses, look how that's answer choice number 1. This would have been wrong. And the Regents is tricky this way. It's going to give you wrong answer choices that you might think are right. So this putting in parentheses part is really crucial and really important. Okay? Use those parentheses. Use your grouping symbols. Okay? Moving on. The modeling process can become much more complicated when the information becomes more convoluted. Convoluted means like intense, complicated. Let's work with one particular age problem next. Age problems are very popular in Common Core, so we're going to have to get used to seeing them. So exercise 3 says Evie and her father are comparing their ages. At the current time, Evie's father is 36 years older than her. 3 years from now, Evie's father will be 5 times her age at that point. How old is Evie now? Part A says, before we start to work with setting up variables, expressions, and equations, let's first do some guess and check work. Try a few ages for Evie now and see if they're correct. Think carefully about the information given to you. So I'm going to try Evie being 10. So let's just take a guess. Let's try that Evie is 10. If Evie is 10, how old would Evie's father be? Well, Evie's father is 36 years older. So that means that the father would be what? Well, what's 10 plus 36? 46. Okay. Now, 3 years from now, well, in 3 years, how old will Evie be? She's 10 now, so Evie will be 13. Then how old would her father be? Well, in 3 years, if her father's 46, that means in 3 years, he would be 46. So this is the information that I know, right? If I'm just guessing that Evie's 10. Okay? But now, it also says that in those 3 years, after that happens, the father will be 5 times her age at that point. Well, Evie's 13, right? What's 13 times 5? 13 times 5 is 65. Uh-oh. Is 65 equal to 46? No. So Evie's not 10. That number doesn't work. Okay? Let's try another number. How about we try Evie being 4? So let's try Evie being 4. The father would be then how old? The father is 36 years older, so then the father would be 40. In 3 years, Evie will be 7, because 4 plus 3 equals 7. And the father will be 43. Same thing, is Evie's father 5 times her age? Well, 7 times 5 gives me, 5 times her age. So 5 times 7 would give me 35, and that's also not equal to 43. This could take quite a while if I keep trying to guess and check, right? A really long time. So there's got to be a better way to try and solve this without guessing and checking. So this is not efficient. It's not easy to guess. So let's be a little more efficient. Okay, let's take a look at B, and this is where we're going to make our let statements. Okay, so I'm going to let, and this is, you have to pay very close attention right here because there's several let statements we have to make. Let's start with the simplest one. Let's let X be Evie's current age. Okay, how old she is right now. Then we can figure out her father's age. How old is her father? Her father is 36 years older. So then I can say, okay, we'll let whatever Evie's age is, X, plus 36, that's going to be the father's age. Current age. Okay? Now let's fast forward 3 years. In 3 years, how old will Evie be? Well, if she's some age X now, if we just do plus 3, that will be her age in 3 years. What will her father's age be? Well, her father is right now x plus 36 years old. How do we add 3 more years? We'll just put plus 3. Okay, so these are all of my definitions. It's quite a bit, but it's really important to do this setup stage first. Okay? Now, I haven't used this information right now. If we look up here, I have not yet even used this Evie's father will be 5 times her age at that point. Remember what I said about this phrase will be being an equal sign? Okay, so Evie's father will be 5 times her age at that point. So we're looking at the future numbers, okay, in the 3 years. So Evie's father currently is x plus 36. In 3 years, he's this x plus 36 plus 3. So x plus 36 plus 3 is this right here, Evie's father. Okay? The will be, here I'm going to circle it in green, that's where I get the equal sign. Now I have to think about this. 5 times her age. Is it 5 times her age now or 5 times her age in the future? It's 5 times her age at that point in the future. So I'm going to say 5 times, what's her age in the future? Right here, x plus 3. So this becomes 5 times x plus 3. Okay? Very difficult problem to set up. But once you let all of your statements come out and you really think about the problem and separate it the way I have up here with colors, it really kind of helps you narrow down what your equation is. And now here's the easy part. Now we would just combine like terms and solve for x. So I'm going to combine 36 and 3 and get 39. I'm going to distribute the 5 and get 5x plus 15. And now I'm going to start simplifying. I like all my x terms on the left, so I'm going to subtract 5x. These cancel out. Invisible 1, x minus 5x is negative 4x plus 39, and drop down my 15. I'm going to subtract 39 on both sides. These cancel out, and I'm left with negative 4x equals 15 minus 39 is a negative 24. Please use your calculators. Divide both sides by negative 4. And I get that x equals a positive 6. Now, what does this mean? Well, let's go back to our variable. What does x equal? X is equal to Evie's current age. So, how old is Evie? Evie is 6 years old. Okay? So that's my answer. Alright? Okay, let's take a look at the very last example problem. Okay, exercise 4. Kirk has $12 less than Jim. If Jim spends half his money and Kirk spends none, then Kirk will have $2 more than Jim. This is a really tough problem. You can try it on your own if you want to see if you've gotten your correct statements, and that's fine. But this is a tough problem, so I'm going to explain this one pretty intensely. Okay? First thing we got to do is make our let statements. Okay? I'm going to let x be the amount Jim has. The reason I'm doing that, and this is kind of a weird trick, when you see a word problem with like a less than or a more than or any type of than in it, whatever word comes after the than, that should be your variable that you use. Your original variable. It's a little weird trick if you see the word than. Okay? So I'm going to make Jim x instead of Kirk. Okay? Now I'm going to define Kirk. So let x, now Kirk has $12 less than Jim. So that means that he's got x minus $12. This is the amount Kirk has. And if you want to test that, pick a number for Jim. If Jim has $20 and Kirk has $12 less, it'd be 20 minus 12. Kirk would have $8, right? And finally, the last thing we need to define is the amount of money Jim has after spending half. So if Jim spends half of his money. If Jim spends half of his money, he starts off with 20 and he spends half, we're really just dividing that by 2. If I have $20 and I spend half of it, how much do I have left? $10. If I have $4 and I spend half of it, what do I have? 2. So I'm just dividing whatever I start with by 2. So that's where I'm getting this x over 2. And that's going to be the amount of money Jim has after spending half. So there's my let problems, my let statements. And now I'm going to try and write my equation with these statements. Okay? So let's take a look at my statement in English here. If Jim spends half of his money and Kirk spends none, okay, then Kirk will have $2 more than Jim. This will have is telling you need an equal sign. So I know there's an equal sign. Okay? So he'll have $2 more than Jim. Well, the amount of money Jim has after spending half is x over 2. So I'm going to put this x over 2 here. Okay? That's the amount of money he spends if he spends half of his money. And Kirk spends no money. So Kirk doesn't spend any money, right? He doesn't spend any money, so how much does Kirk have? He still has this x minus 12. He spends no money. He's still at x minus 12 monies. Okay? Then Kirk will have $2 more than Jim. If Kirk has $2 more than Jim, okay, then we have to put this plus 2 over here. Because that's the side that Jim has on, and we've got to create that equality for Jim, right? Because he's got $2 more. Okay? Because he hasn't spent any of his money, right? This side doesn't change. But Jim spends half, and Kirk has $2 more than him. Okay? So now we're gonna solve this equation. Okay? So the first thing I want to do is I'm going to subtract an x on both sides here. Okay? Now this is like saying I've got 1/2 minus 1. So this becomes a negative 1/2 x plus 2 equals negative 12. Subtract the 2 on both sides. These cancel out, and I get negative 1/2 equals negative 14. Okay? I'm going to keep solving this. I'm going to multiply both. Actually, you know what? I think it might be easier for you to think about it like division. You can divide both sides by negative 1/2. It's good practice to use your calculator. If we divide both this by negative 1/2, you end up getting x equals a positive 28. So what does this mean? This means that Jim had $28 to start. And Kirk then, he had $12 less than Jim, so that means that he had $28 minus 12, so Kirk had $14 to start off with. Oh, I'm sorry, 28 minus 12 is 16. And does this make sense? If Jim spends half, so let's say here's Jim's money, right? That's Jim. He spends half. Boom, cut your money in half. That means that he's got $14 left over. Kirk still has 16. Is that 2 more? Does he have 2 more than Jim? Yes, it works out. So this is like our check right here to see if our answer makes sense. Okay? This problem was shockingly difficult, exercise 4. Very tough. Nothing like this will be on your mastery, but it's really important that you absorb it and understand it, because it could be very likely a problem like exercise 4 could be on your Regents. Okay? I know that this video in particular took the longest you've had all year, but this problem-solving skill is extremely important. And let's remember our problem-solving template, right? If we have a problem, let's insert a page. If I have a problem, what's my template going to say? If I can get my page to change. Remember my template. Number 1 is to understand my problem. What is the question asking? What does it want? Step 2, lay out all the information. understand and put all the information down. That's still step 1, right? So that means your let statements. You don't have to write this down. I'm just reminding you of the problem-solving template. Okay? 2 is your plan. What was your plan? To create an equation and then to solve your equation. This one is execute the plan. So now you solve, right? And finally, your last part is to do your check. Does it make sense? So this template should be used a lot in this unit to really figure out what these problems are asking. Okay? Thank you for your patience with this lesson and your focus. And please, good luck on your fluency. Try these problems on your own first and then check to see if you're correct. And as always, I'm here for you when you need me. Okay?